Okay, let's try to find the general solutions of second derivative dy dx minus dy dx first derivative minus 2y equals to 2e raised to the power of 3x. So from here the general characteristic equation is, let me just write down answer. Characteristic equation is m square minus m minus 2 equals to 0. We're gonna leave this non-homogeneous letter stage, and with this one we will find the roots to be m plus 1 and m plus 2 or minus 2. So the roots are both real and equal, therefore the solution will have characteristic form of yc, if you like. Yc is the characteristic or the complementary function to be a times e raised to the power of negative x plus b a constant times e to the power of, in this case, 2x. So this is actually come from the overall forms of a times e to the m1x plus b times e to the power of m2x, if you like. So in this case we have our m1 and m2 respectively. So in this case our a and b will be constant that we will find later on using the given information, initial and boundary condition if available. However, this is not the case, so let's move on, because this is only finding general solution. So we've done the yc or the complementary function part, and now we have to find the solution for the non-homogeneous part, which is, if you like, fx as the non-homogeneous part to be, in this case, 2 times e to the power of 3x. So in this case the particular solution or particular integral for this function will be in the form of x raised to the power of r times a constant k times e also to the power of 3x. Just bear in mind. So now we have to find a list of the minimum r value that fits the condition. So for example, in this case, if we choose r equals to 0, then the particular solution will be x over 0 k e to the 3x, which is equals to k e to the 3x. So bear in mind that this 3 also come from the original solution, original non-homogeneous function. So from here we can see that there is no terms from in yp that correspond to any terms in yc. So this is yp and then this is yc. You can see that there is no corresponding or there is no common terms between yc and yp. Therefore we can proceed, go ahead finding the derivative of yp, because later on we are going to find the general or the overall solution of the problem given here to be written as, I'll just write down on the right here, y will be yc plus yp. So we've done the yc part, okay, only the general forms, and then we found the particular integral, if you like, yp to be k times e to the power of 3x, as is mentioned here using r equals to 0. So we found out that there is no corresponding, or there is no common terms in yc, so we can proceed in finding the derivative of the yp, the first and the second derivative. Starting from the first derivative, dyp over dx would be, therefore, just taking from the green line there, 3k e raised to the power 3x, and subsequently the second derivative of yp will be 3 times 3 will be 9k e to the 3x. Let's just write down this as second equation and first and second equation. So if we plug, plug 1 and 2 into the main differential equation, which is d square, or second derivative, dy dx square minus dy dx minus 2y equals to 2e to the 3x. Then we can get, so just highlight here a couple of things. For example, this one, this be our dy dp, okay, and then we can use the first derivative of that one. So in here will be, continue from here, 9k e raised to the power of 3x minus dy dx will be 3k e to the power of 3x minus 2 minus 2y minus 2y. y itself is yp, which is, in bracket, let's put k e raised to the power of 3x. This is 2y. So overall everything become 2e raised to the power of 3x. So after rearranging, after rearrangement, we will get 4k e raised to the power of 3x will be equals to 2e raised to the power of 3x. Just a couple of highlighting a little bit. So this one will be highlighted the same as in the terms, pink terms, and then 3k is goes to this part, so that one. Let me just highlight also, and then this is that one, and you can say that this will be the green part there. Okay. So by equating the coefficients relative to the e3x, which is this one, we can see that for 4k will be equals to 2 after equating the coefficient. then we will get for k is equal to 2, which means k equals to 2 over 4 equals to half. So if you like, I can highlight this part equals to this part, and then maintaining e to the x, e to the 3x to be exactly. Therefore k equals to half. Therefore the particular integral will be that we already write down before. Therefore the particular integral yp is therefore half times e raised to the power of 3x. So we've done yp, so also we also done the yc part. Therefore the overall, okay, the overall general solution y is yc plus yp, which is a times e to the negative 1x, negative x, plus b times e raised to the power positive 2x plus half to e raised to the power 3x, which is the overall or general solution of the problem, differential equation problem.